everyone. Welcome to another video in the Master Data Management in SQL series. My name is Elric, and today's video is going to be first of many on definitions. This is where our system starts to develop. This is where we start seeing patterns. This is where all the craziness, the mental games, this is where it begins. The first videos prior or previous to this one, awesome. We are just building the system, getting our tasks out of the way, but now we start to see the system work as it should work. So it's just gonna get not necessarily more complicated from here, but hopefully from this video forward, this is where all of your ideas and all of your aha moments will start to happen. If they haven't happened before, they will start happening. So this is a definition video, and this specific video will be on defaults. We're going to go back and we're going to fix some of our create tables so we can create more types more effortlessly and not run into all of these errors. So the first thing I want to do is open up my definition table, and we're going to insert another column, but this isn't a parent ID, so we are going to place it after the sequence but before our system columns. One moment. Excuse me. We are going to give our definition column a nullable process ID. Some of our definitions, actually most of our definitions, will require processes. So we want to just go ahead and do that, and we're not going to foreign key it. We're just going to leave it at that. So it also filled in some definition, class, family, and types, just to get started. This is going to be a pretty long video. The class is the data point type. That is what we are going to be working with first. We moved out of the process, we're into the data point type, and then we'll turn around and focus on the database and the data sets in our spiral. So the first definition, data point type. Now under those definitions, we have a few different families of definitions. I have one for defaults, one for clustered index, non-clustered index, and a unique index. I did not choose one for defaults and one for indexes for a very good reason. Because our next set, they're all common definitions. This means that if we have a special definition for a data point type class for a default, we are actually going to put the data set in here. So we are going to look up first if there is a special definition. It won't say common, it'll actually say maybe we have a special, for an example, maybe we have a special clustered index definition on our dataset table. Well, when we create the query, we're not going to look up common first. We're going to look up any definitions that belong to our dataset table using the dataset key name here. So we'll have record 5. And it will run those instead of the common definitions. So that's what we'll program in if there are no specialized definitions, and we'll program that in so we can just data drive it or drive it via data. then it'll just default back to the common definitions. And then we have our definition table, which is empty right now. So I'm gonna go ahead and close everything but this. I'll just close them all, doesn't matter. We are going to create a couple functions. I'm going to get started. I apologize. I'm going to go ahead and get started with the development. You can follow along if you'd like, or just watch. Either or, we're going to have some fun. So we need to create a couple of definitions because we only want to do this one way. I'm going to create a function called reflect bit true. And we're going to save it in our interface main. I'm going to create one for false. We're going to save it. I'm going to create one for null. And it's going to be a string null. And we're going to reflect it. Returns null. And then I'm going to run my process finder that we created in the last video. Excellent. So we are going to go back to our definitions. And I'm going to insert first let me make sure I'm in interface main. Data point type, because this is a class of definitions. Actually, no, we'll add an unassigned default too. That'll work. We'll add it as a null. So I need to create definitions. And these definitions, being under the DataPoint class, are going to be modeled after our DataPoint type class, are going to be modeled after our DataPoint type. Do I want to do it this way? Nope, no, I don't. I do not want to do it this way. I want to do it a different way. This is a new way, haven't done it, but I'm going to now. Null default definition. And I'm going to enter that as a definition. I'm going to enter another one as a true default definition, a false default definition, and the specific dataset number default definition. So under the DataPoint type class, default, common definitions, I have null, true, false, and specific. So I'm not going to edit these, so I can easily open up my processes and find those functions that we added. So 25 is true, 26 is false, 27 is null. 25 is true, 26 is false, 27 is null, and seven is specific dataset number. Not all of our defaults are going to be functions, so we're going to actually have to look up this ID and look up its family and handle it differently if it was a function. But that's okay. So now I have a null default, true, false, specific, ready to go. So I want the str name, str key name, the sysref definition ID, dataset number, from the definition table, and the same thing from the DataPoint type table. And I chose these specific dataset numbers accordingly. So here's where our relationship comes into play. And this is our first relationship, and we are relating two ref tables together, so we will be operating under the system reference relationship. So I've not added rows in here yet because I really wanted to describe what I'm doing as I'm doing it. This is a definition to DataPoint type realm. And it's very important that we think of it as we are operating in the definition subject, and we just need data point types. It's not the other way around. And it'll make more sense as we fill this up with other definitions, especially revolving or regarding data point types. And with a key name, I try to create key names that let me bring this over, that have some sort of unique in between that I can replace that should never appear anywhere else. So I'm going to use -2-. So if I go in and I use SQL's split string function, or string split, and I forgot what the first word was, I could split on space -2-, and then I immediately have the subject names, and I can immediately go get the base table or the relationship table, whatever is related, all programmatically. So we're going to put some intelligence into our key name, because once a key name is declared, we should never touch it. Not unless we know exactly what it affects, the full scope of it, and we need to fix it. So that is why we use key names instead of names. And that's why we can give things meaningful names. So that will be our first realm. And then our class, this is really a structure. I mean, all relationships are structures, but I mean, this really doesn't have a, it's not a tree. So I'm just going to give it the word structure. In the family, is going to be direct. I might not have it here, but I could easily add ancestor and descendant instead of direct. And then with one key name, I can cycle through direct relationships, parent-child, being right next to her or next to each other. Descendant relationships, where the parent is the level and the descendant is everything underneath. And that is where our class comes into play, because underneath what? Right, we can have a group to people relationship realm, but maybe our class relationship is some other factor where we need that descendant data set. And this is to avoid CTEs. So we're not going to be processing data through this structure. We'll be running a CTE once every time this is changed in that specific realm. A CTE will happen, or we'll run, fill our ancestor and cascaded, and we'll never use that in code. We'll only do where in, ancestor, cascaded. So there's a lot of your processing time gone if you ever had to use recursive CTEs. And for our relationship type, we're just going to give it the word member, because it's just a member. So if I go back up, and I believe my database finder is my go-to because of the system. I can take that where in system. I'll minimize this, replace system, it's system, reference, relationship. Oops. So that is my relationship ID. And now we're going to relate these together, albeit manually, because we don't have that, we don't have that UI yet. So, to insert into DBO table relationship, reference relationship, I'm going to grab my columns. And the tenant being in here is also very powerful because you can have different relationships for different things depending on who is using the system. Sweet. And my values. Now I'm going to reverse this. I'm going to collapse it down so it's easier. And you will see why. Actually, for ease of reading, we're going to take some things out and let the defaults take control. Just because it's going to be easier to read. Declare at relationship type ID def2 If I run this again, just to make sure. All right. So my specific dataset number implied, being that the word definition was first, is going to be 30. Row ID implied, we're going to say null. This is a direct relationship. My child's table number is 17. Close this off, put a 0 here, copy and paste the row, and kind of go through our list for nulls. So, name, key name, description, abbreviation, header, display, sequence. Primary keys do not have defaults because of their identity. Cleanse2 is a null. Foreign key is a null. Foreign key implied is a null. Specific dataset number. We actually have it as a special function. Specific dataset number implied. 13. Oh, that should be a 12. 13 is a null. The source is a null. And then we go into our active and valid flags. So I'm just going to create some space. So true is 2. Active valid 15, 16. Our true. (17) is archived, which is a false. Display planned other security cleansable. Display planned other security cleansable. All false. Let me bring this guy to the top just to give it some separation. Tenant taxonomy. Oh, I froze. Oh, don't run out of memory. I do wish SQL wasn't a 32-bit client and could handle more than 2 gig. Ugh. Alright, lost my spot. 22, 23 is taxonomy, appears null. 23, taxonomy, null. 23 tenant, 24 taxonomy. 25 cluster group. 26, 7, 8, 9. 6, 7, 8, 9, 30, 1, 2, 3, 4, 5. All the rest are nulls. So, now using the relationship table, we've created our first essentially relationship for a very specific relationship. So now the first thing I want to do is go back to our create default. My eyes would adjust. There we go. Our update. And let's see. Nope. That should be good. We want something on the outside of this. So we create a definition. I'm going to use Dataset ID 1. Actually, let me see. Yep. I'm going to use Dataset ID 1 because we don't have very many defaults on here. So if I pass this Dataset ID 1, what do I need to do? I need to figure out the data points that I have. The data point that it is, data point type ID. With the type ID, I will get the relationship. I'm actually going to go back to our insert statement and grab this code, because I will need it anyways, because we have not procedurally built our functions yet. There we go. So to give you a dataset ID, I will need to grab all of the data points inside of the data set and find their type, and then find their key name. Given the current relationship that I have, I will need to find out what is your definition ID. With my definition ID, I will need the process type ID. With, just the process ID. With the process ID, I will need the process type ID and the process family ID from the type table, which should lead me to the key name, which will tell me if this is a function or a procedure. And then by executing that, I will get a default value. And if I have the default value, the dataset ID, and what did we do this? Data point name. Well, I could just pick that up on the way. Now, I can dynamically get all of my defaults and my definitions. Sweet Christmas. So, let us do that. in the data point ID from the data point table, where our dataset ID is the incoming ID, because we're going to replace that alter in all of our creates. And essentially, when we create the table, we're going to make sure that it's in the dataset table, and then we're going to make sure everything's in the data point table, and then we're going to send that dataset ID forward to kind of finish getting our objects set up. Probably not all of that in this video. I might have to create a separate one when we get to creating more and more shapes. Now, we're going to get rid of code, and that is the best part. Add code, but we're going to get rid of crappy code. We're going to normalize a process, and that's what we're going to do. That's what I'll say. We are going to normalize a process. So, okay. Running through, I have my data point type IDs, so select data point type key name equals str key name from where make sure to null this out. Got my key name. Now I know what definition. Wait, darn it. No, because I related the type IDs. Darn it. Oh. It's morning time. My brain's hasn't fully absorbed the coffee yet. We want to do two more things. This is specifically for our clustered indexes that we do not have yet, but this is what's going to keep our relationship fast. And these are going to be on the outside. Select specific equals and specific data set number source from dbo.stblref data set where str key name equals definition, because we do not want to look up by And these are one of the functions that I'll procedurally create. So I'm going to use a select statement for now. Oh, I'm lagging today. Bam. So we got our type. Our parent. Which is part of the cluster. And then we're going to order this appropriately. Excellent. So we'll get a definition ID. Process type ID. Oh, we're in the process type. No, we're in the process table. Process family ID. And you're wondering, if you are wondering, Elric, just join them all together. Should be Elric, why don't you join them all together? And it's because, yes, we deal with set theory. However, joins cost time. You're looking at record per record, and you're trying to do large matches. So it does make sense if your data sets are limited to join, and these are not limited. These have many different things attached to them. So I think I'm going to use a join and a couple views, that spoke views, that we're not ever going to use in code, in production code. So that's, you know, it's hard to explain. We'll have to get into, I'll have to have this system up and running so you, the viewers, can send me data and be like, well, I used a cursor on this and it was horribly slow, but I had a join, it was horribly fast. You give the data to me, I model in my system, and we just test, because that's science. There's no right or wrong. There is a true statement until, you know, falsified, proven falsified, or blah, blah, blah. We have to adapt. That's what we have to do. Now I need my dynamic statements, and I'm getting kind of big code here. Execute parameter. Oof. I'm not ready to handle one thing. Darn it. That's okay. I am not ready in this video to send JSON to functions and allow it to tell exactly what it needs. Instead of trying to figure out, should I send it a dataset ID or a data point ID, we're essentially just going to send it JSON and the function will know what to get. It's pretty cool. It is phenomenally, like, it makes life so much easier. But I do not have it set up. So this is gonna have to be pretty simple. No problems though. Walk, don't run, and all that good stuff. Yep. I believe this is correct. If I ignore it. Ha! Knew it. I mean, I didn't. I tested it, but I had a feeling. Sweet. Place. Oh. Execute SQL. Just kind of speeding along through this. Trying to. And I'm going all the way back up because I did not declare. Process name. No, and it's not an integer. Ah, that's not an integer either. What else did we mess up? That's not an integer either. Okay. Alrighty. Now we get the required default value, and then we should be able to reuse this code. Make sure that I got that. And I did. Alrighty, so we did not need the key name after all. So let's go ahead and just make sure we're not overriding variables. Copy all these things. That we use internally. We're going to null them out. Kind of as a warning sign. Hey, these are null. Wish SQL would actually do that. All right, moment of truth. Did our relationship stuff work? With no clusters, no nothing like that. Kind of curious, how this is fast is going to run, what's going to do. And did nothing. Sweet. So let's see how far it got. Not getting there. We're getting here. We're getting here. So that's good. Name ID, type ID. Let's see what this is. No, all the way down. Bam, found it. Oh, definition. All right. Nope. What else? Are we making it down here? Yes, but it's no process name. Process name. All right. Sweet. There we go. Let me remove the print. Little stuff. So let's see how fast we are looking. Bam. built it. So that's awesome. That's how we can ensure all of our defaults are the same. I'm gonna copy all this code, and I'm going to create a new utility. This is under the dataset, DataPoint. Yep. Default. And what does it do? It updates them. Dataset. So I'm kind of curious, because this first time I've done it this way. I want to, let's see, data point finder. I'm gonna grab this dataset cursor. Essentially, I'm just gonna delete everything in the middle. Close this, open a new window. I don't have a lot of stuff in here, not a lot of records, but I'm always curious to see, what's happening, what's gonna happen. So I'm just gonna make sure I have the Dataset ID. Can this run? I'm just gonna run it. Oh, okay. That's fair. And I'm curious to see how long it's going to take to make sure all of our defaults are up to date and exist. Oh, sweet. So I'm altering. This is a great point. So I use local fast forward for a lot of different things, and I use static for other things. This cursor failed because I was modifying the dataset table which it runs off of. So we have to change this up. If we can spell correctly. We're modifying the table we're accessing. We need to make sure that we capture the data and run through it. Now let's see how fast to rebuild all defaults, call 17 functions per data set at least, plus a procedure that's going to do checks. I mean, you know what we're doing. A little slow. What? Is it all of them? Oh. Because we're trying to update the data point. That is fair. Utilities are a little tricky when it comes to the operation of our actual system. That's not so bad. I got 3 seconds. For no clusters, no indexes, no nothing. So I'm gonna write that down, 3 seconds. In next couple videos we'll be going back and we'll be doing the same concept, but now we're gonna start building clustered indexes and non-clustered indexes on things that we use very frequently, like you can tell with, you know, getting types through key names and all that sort. Make sure our relationship table is in tip-top shape. So 3 seconds. Write that thing down. So we're gonna see if it changes when we normalize the heck out of the storage. So that is all I have for today. For our defaults, in a future video we'll go ahead and replace some of our code in our subject creators, so we're not doing it this way. We essentially want to create the table, and then we're gonna make sure the table's in the data set, and then we're gonna replace all this crap because we don't want to do this. This is not data driven. So that is what we are going to change, and eventually we'll be get rid of these stored procedures entirely. So thank you very much for watching. My name is Elric, and haven't really decided on the next video. I think I want to go into view creations. But yeah, you have a good one, and I will see you next time.